Hello, 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 biologists, and welcome back to example 3 of single trait crosses. It is Mr. B here once again. I even added my email down here, so make sure if you're having any trouble, you can email me, or if you'd like to request any problems or anything, I am open for requests too, because I want to make what is most helpful to you all. I will be continuing to make lots of videos, so feel free to look back at these as we go on. And check this out, I really upped the production value this time. Ready for it? Whoa. I know, that was pretty amazing. Let's do that one more time. Whoa! So that's just to draw your attention back to these 5 steps, since I won't explain them all this time, but they are just as important in every problem, and we're going to use them as we go through all these examples and through this unit. So, dimples is a dominant trait. Both parents are heterozygous. What are the genotypic and phenotypic ratios of their children? All right, so once again, we're going to have to read this question very carefully and use that to help us get through these 5 steps that get us to the end of our problem. So you may be used to dimples right now, but that's fine. We're still going to go through all the steps because as soon as we toss in another allele or do some different trait, then it's gonna get good to just know these steps like the back of your hand. So our first step, once again, is to define the alleles. That means we have to set the letters that we're going to assign to the dominant and recessive allele and figure out which trait is the dominant one and which one's the recessive one concerning dimples. So I'll give you a second here. Feel free to pause it and set your alleles. All right, good job. So, number 1, dimples is dominant. It says that right in the first few words of the problem. Dimples is a dominant trait. So we're going to give it a capital D. Then it says we can just figure out that no dimples is then recessive if dimples is dominant. So it's going to get a lowercase d. Again, the most important thing here, pick letters that look different, uppercase and lowercase, please. It makes everyone's life so much easier. So in this case, D works perfect because an uppercase D and a lowercase d look very different. So now next we have to determine the parent genotypes. So I'm going to give you a second here. Read the question very carefully, pause this video, whatever you need to do, and try to figure out the genotypes of the female and the male parent. All right, so you may notice this one's a bit different than the last couple because both parents are heterozygous. We see that in the second sentence here. Dimples is a dominant trait. Both parents are heterozygous. But it's up to you to read that and figure out, hey, they're saying both parents are heterozygous. That can tell us the genotype. Because heterozygous, as we looked at last lesson, means that you have a dominant and recessive allele bunched together in your genotype. You have one of each. So heterozygous and heterozygous, both parents have a big D and a little d, or a dominant and a recessive allele. With that in mind, try to go on to the next step and figure out the gametes for each parent. All right. You do it? Okay, sure. Let's keep going then. And number 3, we have 2 heterozygotes. Remember, heterozygotes is the word for a heterozygous individual, a heterozygote. So here we have 2 heterozygotes, a female and a male, and they're both going to have the same gametes because they're the same genotype, and they both have both alleles. I'm saying both a lot, but each of them has a dominant and recessive allele, so they could each pass on either one. So both of them can pass on 2 different alleles here, the dominant and the recessive one. This is where we'll see there isn't an easy way, quotation marks. We're going to have to do the whole Punnett square because both parents are heterozygous and have 2 possibilities. So with that hint in mind, make a Punnett square. You can pause it here, figure this out, see how it would map out, and work ahead here. All right, so there's a lovely little Punnett square thing there. Remember, female goes on top. Even though they're the same here, just remember that because that's going to help you and save you marks on an exam or something because that's just a rule that biologists have for some reason, so make sure you follow it. So the female on top, that's a big D and a little d, a dominant and a recessive allele. Then, along the side, we're going to get the male, big D and little d as well. So now we have to cross each of these boxes. We'll see if we meet here. We have a big D and a big D, so that'll be two dominant, or homozygous dominant. Here, big D, little d, and little d, little d. So there we go. So we see here, we have different phenotype combinations here, and different phenotypes. Before I talk too much about this, I'm going to give you a second to go to number 5 and try to figure out these phenotypic and phenotypic ratios on your own. Good luck. All right. Okay, so ratios. Here, before I actually show the answer, I want to show you there are 1, 2, 3, 4 possibilities. So then to find the genotypic ratio, you're going to take however many of the ones you're interested in or the one you're currently looking at, count how many there are, and then divide them by the total amount of possibilities. So we see that here. We have 1/4 capital D, or homozygous dominant. So there's one homozygous dominant individual out of 4 possibilities. So that's 1 out of 4. Then we have 1 out of 2 heterozygous. That's because we have 1, 2 of them, and there's 4 possibilities. 2 out of 4 reduces to 1 out of 2. Math. So we have half of them are DD, and that makes sense because there's 2 of them here out of 4 possibilities. And then we have 1/4 homozygous recessive. That's our little d in the corner here. So 1 of them out of 4 individuals. Now the twist here is our phenotypic ratio is going to be a little bit different than our genotypic ratio. Even though we have 3 different genotypes present, we only have 2 phenotypes because the heterozygote is just going to look the same as the homozygous dominant one. So that means everyone that has a dominant allele, like these 3, they're all going to have dimples. And then the only one that doesn't is the one that doesn't have any dominant allele, so they're going to have no dimples. So we have 3 out of 4 have dimples, that's 75%, and 1 out of 4 doesn't have dimples, that's 25%. Great. I will remind you, feel free to email me requests for videos at this email address. It'll also be in the description of these videos. I hope you have a great day, and I hope these are helping. Keep a lookout for even more to come. Cheers.